In this video, we'll prove the Bayes theorem. For more on probability, you can subscribe to this channel. We have a question here, and we are asked to prove that probability of A is equal to this. And if probability of A is greater than 0, then this. It is called the Bayes theory when I received this question. So we say if B1, B2 to Bn are mutually disjoint and have non-zero probability, and if the set A is a subset of the union B1, B2, and Bn, then this. The first thing to do, I think we should put this in a diagram. Let's say this is B1, B2, B3, and B4. They said they are mutually disjoint. This for diagram 1. It then means that you can draw it this way. That is here, A intersection B1, A intersection B2, A intersection B3, and A intersection B4, as we have it here. So since they are mutually disjoint, let's take this as our A, and the whole of this as our B1, B2, B3, and B4. Of course, this is our union. This is the union of this set. And they said the set of A is a subset of the union B. So it then means that set A is equal to A intersection B1 union A intersection B2 union A intersection BI. Where A intersection BI intersection A intersection BI is equal to a disjoint set. So from this set, we have that the probability of A is equal to the probability of A intersection B 1 union the probability of A intersection B2 union the probability of A intersection BI. So since we have it as union here, it then means that the probability of A is equal to the probability of A intersection B1 plus this union is plus the probability of A intersection B2 plus it continues to the probability of A intersection BI. So the next thing to do is that we'll recall that the probability of A condition B, that means the probability of A given B, is equal to the probability of A intersection B all over the probability of BIs. If we take this as the subject, it means we get the probability of A intersection B is equal to the probability of Bi multiplied by the probability of A given B. Of course, this is equal to the probability of A. That means probability of A intersection B is the probability of A. So the next thing to do is that for this function, the probability of A, they said we should show that it is this. It then means that the probability of A, which is this, is equal to the summation of the probability of Bi. That means for this function, multiplied by the probability of A given B. So this is the first. So we succeeded in proving the first one, which is this. For the second one, for the second question, that if the probability of A is greater than 0, then the probability of B given A. And let us say from the diagram, which is this, these are mutually disjoint sets, and we brought them here to be A intersection individual sets. So it means that the probability of B given that A has happened is equal to the probability of B intersection A all over the probability of A is also equal to, like what we wrote before, the probability of A intersection B all over the probability of Bi's. Therefore, the probability of B given A is equal to what we have here, the probability of Bi multiplied by the probability of A given B all over summation of the probability of Bi's multiplied by the probability of A given B I's. So this is for the second one. We have succeeded in proving the second one. It is called the Bayes theory. So this is how the Bayes theory for conditional probability can be proved. First, if we have mutually disjoint sets and A is a subset of the union of these sets, that is how we prove this. For more on this topic, you need to subscribe to this channel.